Most of the e-commerce applications have this problem. The dashboards that are created are well as stale. Their logs live in three different tools, and the AI chatbot has no idea what the customer wants. ShopKit fixes all three in one single stack application powered by ClickHouse. I'm going to show you a running prototype how we can do all this, clone, and make it live in 5 minutes. What's the problem that we're trying to solve? The blind spots in real time. E-commerce teams make decisions that are day old because of batch processing. By the time you get to know there's a problem, the customers would have already moved on. Siloed observability, application logs, clickstream data, and server metrics live in all three different tools. There's no single tool for the observability. Zero context of what customer wants in the AI. And conversion funnel is a black box. So add to cart, checkout, drop-off events exist only in marketing tools which are disconnected from the backend performance data and server error rates. So what's the solution? So we are going to break this solution down in three parts: the real-time clickstream, full-stack observability, and context-aware AI. Let's go into detail for each of these three. Now, before that, let's see what's the system architecture. The system architecture is broken down in three tiers: the app tier, the ClickHouse layer, and the AI and observability tier. So for the app tier, we have our own React Express, Postgres to maintain the transactions, authentication using JWT, and containerizing the entire application using Docker. And also, if you want scaling, you can go with Kubernetes as well. And for ClickHouse, we have the tables that are created for click events, for server logs, for app logs. Along with that, we have ClickStack and HyperDX for sending the OTelemetry logs and the traces on the UI to the ClickStack. And also, we have enabled the ClickHouse layer for the MCP so that these MCP tools can be used further. And the AI and observability tier. Here we have LibreChat powered by Gemini models and HyperDX UI for observability, and all of the logs are coming through OpenTelemetry. And we also have MCP server connection to the ClickHouse tools. Okay, let's see the schema of the tables that are created in ClickHouse. So we have divided all this entire application into three tables basically. So one is for click events, where all the actions that user performs on the UI will be stored, and one is for the server logs. Any action taken by the user that comes to the server gets logged and gets stored in the server logs. And finally, app logs. So if there are any info level logs, warnings, error logs, all of these are going into app logs, and using OpenTelemetry, it is transmitted in real time to HyperDX or ClickStack. So let's see how the entire thing goes. So user performs the action in the ShopKit application. So when he clicks on page view or add to cart or checks out, all of these are tracked into queues. And once the queue reaches the 5 seconds time limit, and with 50 events cap, it gets flushed, and API is called from the server for which is API slash events, and then which finally processes these events and inserts these into ClickHouse. So these are some of the events that are tracked: page view, product search, add to cart, checkout success, logout, etc. Now observability with ClickStack. How? So we are using online OLTP export with full stack visibility in HyperDX. So as a middleware, we are using our server, which uses OpenTelemetry to constantly export these logs into ClickStack. And then on HyperDX, you can have dashboards based on these logs, and you can create histograms, pie charts, and any of the charts in your dashboard that will serve your purpose. And all of these logs are structured using a logger.js util that is created that actually formats this logs in a useful way so that you can extract attributes in it and use it for analysis. Okay. Now the AI shopping assistant. So this is an assistant that lives inside the application itself. So where users can query some of the things like what's the price of the wireless headphones, what are the things that are in the cart, what is the what is the stock of a particular item. So all of these things can be asked in the AI shopping assistant within the application itself. So it has context to what the users are performing. It has optional auth if user has to perform some actions, and it is embedded directly within the chat. Now let's see how we are using LibreChat with the MCP tools powered by ClickHouse to query some of the tables. Sorry. So we have the LibreChat UI, we have the MCP server from the ClickHouse, and we have the ClickHouse itself, which hosts our ShopKit tables. So every time you ask something from the Liber chat, it connects to the MCP service. It understands the context and it understands what is the tool, what is the particular tool that needs to be called for the ClickHouse, and once you make a tool call, the ClickHouse in turn executes that SQL and provides the result. And again, the Liber chat UI formats the result that it got into insightful information. Some of the queries that you can ask is what are the top five products that have been added to the cart this week? What is my P95 latency for API/orders? What is the checkout conversion rate for last 30 days? Well, this is one of the important uh, use cases where you can easily ask in a human language, and you don't have to know how to query ClickHouse, and it gives you relevant information. So, what is the stack? So that the stack that we are using is ClickHouse to maintain the tables. As I said, all the server logs, app logs, all of these are going into the ClickHouse. And we have ClickStack or HyperDX for creating the observability layer, and LibreChat, of course, to query the ClickHouse in the normal conversational pattern and get the response that you need, get the insights that you need. And why this wins? It is shipping something real. So an entire stack can be deployed by just running Docker Compose command. Speed is the story. So ClickHouse makes the impossible Postgres queries where all of our transactions is stored, which is much slower to query than to query on the ClickHouse. Then we have all of the three stacks in one: the real-time analytics, the observability, the agentic AI pipelines, and the live chat. So now let's see the real-time demo for our application. So this is our simple demo application for the e-commerce application. So here we have the list of products. You can add to cart, you can search for the products. Let's see, let's search for wireless headphones. So it gives you all the wireless headphones that it has. And you can also add to cart. And once you've added to cart, you can also order them in checkout, and all of these would be present in the orders. So now let's see how this can be used in the ClickHouse. Okay. So first thing, let's see on the ClickStack how we can see these transactions happening in a dashboard. So here I have created a sample dashboard where I have two charts, where one is a breakdown of page events by event type. Okay. As you can see, as soon as I refreshed, you can see there are some of the click events that have been captured. Okay, as you can see, the event types are like cart, API call, orders click, checkout. So all of these events I just triggered in some times. And here I have API call statuses. Here I have count of all the API backend API calls that are happening and what are the statuses. As you can see, it is a breakdown of post, get, the REST API methods by their statuses. You can see how many post methods have 202 status, how many have 200 status get, and what is the path that is being called as well is present here. So as you can see, get slash categories is one, and its relevant status is also present. So this is a sample use case for having the click stack. And now the most impressive part is the LibreChat. Here I have pre-made an agent with uh, with using OpenRouter as the model and MCP server for ClickHouse. Okay. Here I have given some instructions so that it can understand my conversation and gets to know what exactly it has to do to query these logs. Okay. Let us try some of the queries. Okay. What are my latest 5 events? As you can see, it is connected to ClickHouse MCP tools for running the query. It also understands the context of what query to be run, what is the database to be called, what is a table, what are the columns. It has context to all of that. As you can see, after performing the query, it is giving the response in a structured format. So it has told that there was a API call for API slash products, and then there was a click event, API call again for categories, page view. So these are the top 5 click events that have happened. So if you don't believe if this has produced the right response, it has also given you the query that it has executed. So you can copy this query and you can go to any of your popular database client tool, just configure the ClickHouse server here, log into your database, then run the query that you just copied here, and you can see it has produced the exact same 5 results that the chat had produced. Now let's see a different one. Okay. Now let's see page by event type breakdowns for last 30 minutes. As you can see, it can also understand the relative timings. I've just mentioned it as last 30 minutes, and it understands that it has to query from now to it captures the timestamp now and goes back 30 minutes and it adds the query. I need not know the schema of exactly what is a page, what is an event. I need not know the schema as well. Okay, as you can see, in last 30 minutes, this is the breakdown of all the events that have happened. Again, as usual, let's copy this and query it here. It's the exact same query and the result, as you can see over here. Okay, now let's see how do you clone this application and run it for yourself. So I will be linking this repo with you, and you can use this, clone this, and it has instructions on installations as well. So if you were to install all of them individually, you can run all of the npm packages, install yourselves. But what's even better is this is already packaged in Docker Compose. So all you need is just this one command, which will which will look at the Docker Compose YAML, and it will install all the things that is necessary. Coming back. So once you have installed everything, you also need to configure some things on the environment. On the environment, you can give your API keys here. So I will not be detailing like how do you generate these API keys, but for Google, for Google key you can have to go to AI Studio and generate the API keys, and you can use the API key over here. And for AI native API key, you can go to AI native's official website, generate your API key, and put it over here. So that's all for the demo today. Hope you liked it. Thank you so much.